Hi, Stephen. How you doing?
Hello.
Hi, how you doing? You all right?
Yeah, I'm pretty good.
Good, excellent.
How are you?
Yes, not too bad, not too bad. I think this is officially the halfway point for the week, which is nice.
Oh yeah, that came around quickly. I've almost lost all sense of weekdays at this point.
It did, yeah. I mean, I know you're obviously busy as well. It's been a funny one. I mean, it only seems like yesterday we just came back after Christmas almost, and at the risk of sounding like an old man, time really flies, doesn't it?
Yeah, I'm with you there. It's I think it's just since kind of lockdown and all of that, it's felt like time's gone so quickly.
Absolutely. It's yeah.
It's kind of nice now that things are opening back up, and I don't know. It's just as any remnant of new experience is welcome, I think.
Yeah. We've been somewhat constrained the last 2 years, I think. So yeah, it's certainly a nice feeling.
Oh, Zoom really likes making it so that I can't see anything when I share. Can you see that?
Yes, I can see that.
Cool.
No worries.
I've got a total of 5 screens in front of me here, and I'm using all of them. Ridiculously complicated, but should be good.
I like how you managed to put yourself in the middle of the kind of frame, and that's really cool.
So this is I do a fair amount of like live streaming on Twitch, and I'll do I'll do live coding. I mean, Lexoral does it a few times a week. Is going to be. So it's all using the same setup that I do for that. I'm essentially showing the preview of what I would be streaming on my screen, and then screen sharing.
Right.
So I can I can do this kind of thing.
Yeah.
And swap between them. Should be good.
I think this is the most professional, certainly aesthetic effort that we've had so far on We Are Tech. So it's a good start.
Yeah, I wouldn't say that it's effort. I've reused things that I already had ready.
Right. Cool. Yeah, we'll just give it a few minutes and let people join. See, we're color coordinated as well. I mean, it's not an official uniform, but
it's not very difficult because I basically always wear this outfit. I went through that almost. I don't want to compare it to Steve Jobs. I'll say it's more Tom Scott than Steve Jobs. The realization of, I've got all these T-shirts and this one's my favorite, and I get sad whenever it isn't ready. Why don't I just buy 20 of these and get rid of everything else?
It's a Lexoral look, Stephen. This is what it is.
Oh God. Yeah, it's
consciously or subconsciously. It's this is part of the personal branding. Exactly. Now, I think
that's it. I think everyone watching, if you're not wearing this outfit, sorry, you're gonna have to leave.
Before he died in 1891, he was actually the last native speaker. There is evidence that he got that. But it's not until the 1920s that the move to re-establish it really happened. When it might have been particularly useful to speak the language, yes, there has. Already these formal speakers of the 16 and 1700s, it was becoming a usual language to find. So it's
That's funny.
People who spoke the language. Before 2000, it was officially recognized.
just give it another minute or so and then we can get started, I think.
Sounds good.
Cool.
Oh my god, ఎవరు జాయిన్ అవ్వలేదు.
Cool. So I think we'll just get started. That's 26 joined so far. There's another few still to log on. But yeah, I think firstly, obviously, a warm welcome to everyone. I think this is our 12th We Are Tech meetup today. So as you'll be able to see from the screen, delighted to have Stephen Waterman with us today, who is the founder at Lexoral, based in the Northeast, and he'll tell you, of course, a little bit more about what he's doing shortly when I hand over. But for any of you who are new to the group, just a quick bit about what we're all about, essentially. Obviously, we're an online meetup based out of the Northeast, but yeah, we're open to people from all locations, be that domestically or indeed further afield, Europe or globally. We're very keen to have people's input, and we want it to build a community as such. So, you know, if people have something they'd like to speak on, or they'd like to suggest a topic, do obviously get in touch. I'll pop up my slide at the end with my email address and contact details. And yeah, we'll obviously do our best to facilitate that. I'll say just now the event will be recorded and put on the YouTube channel. So if you don't want to appear on camera, then do obviously keep your camera off. So yeah, I think that covers us off very nicely, and I'll hand over to Stephen.
Fab. Let's make sure that you can all hear me. Yeah, brilliant. Bear with me. I just closed the wrong thing. It's always good. Well, welcome in. I hope that you're all doing well. I hope you've all had a good day. I hope you've all got yourself a drink, something to eat, some kind of snack. I'd hate to think that I was taking up your lunch and that you were left wanting. But yeah, welcome. I'm Stephen. Let's swap over to this. Look, it's a picture of me. So yeah, I'm Stephen. I used to work at Scott Logic with Matt, I think Martin as well. I left there to go and work at the NHS. It was questionable. I didn't last too long there. I'm very much clearly small teams, small groups, and that is what caused me to actually leave the NHS and start Lexoral. So here's Lexoral. Lexoral is a software as a service product that I made for my partner. So my partner's a PhD student. They're doing a longitudinal, PhD thesis. A lot of interviews. You know, he's got like 20 plus hours of interviews, and each of those hours of interviews needed to be transcribed. That transcription took so much longer than you'd expect, and it ended up being around 10 hours of manually transcribing for every 1 hour of actual audio. So we'll add another 0 on the end of that, and it was about 200 hours of work to do this task that, frankly, I looked at and said, yeah, that must be it. We can automate that. We must be able to. And we could. You know, there are plenty of websites that would transcribe your data for you, but every single one of them had an issue. They were either ridiculously expensive or just generally like terrible quality, or they wouldn't understand that kind of domain specific language, or they were shipping off your data to the other side of the world and selling it to advertisers, which we're not a fan of, given that that data is vulnerable people talking about the most sensitive like times of their lives. So it wasn't great. And Lexoral just tries to essentially be what you would want that service to be. So it's privacy first. It's an alternative to manual. You're getting all the quality that you get with a manual transcription. Even though it takes a little bit of work for you, you end up with the same quality, all the privacy, and it kind of isn't too expensive. But it's probably not that relevant to you, to be honest. That's not why I'm here. I'm not trying to sell Lexoral, and that's not really what we're talking about. If you're a user researcher, I mean, feel free to get in touch. I'm happy to give you some free credit. I need users to test it and let me know if it's working. But we're not going to worry about that for now. What we are talking about today is a blog post that I wrote. And this was maybe a month or so ago. And we're going to be covering similar topics, but not completely. So do feel free to go and read this afterwards. I'll have a link at the end. Essentially, we're talking about data layers and databases. So the reason that I'm talking about that is because there are so many assumptions in the way that you do a database, you do a data layer. And a lot of those assumptions, actually, it turns out that they're not invalid, but there's too much of just kind of copying what everyone else does. And by kind of going back to basics, we can find a new way to do it. So that's what we're going to be talking about. We're going to be talking about what Lexoral's data layer looks like and kind of what you can take away from that as well for yourself. If at any point I'm going too fast or I'm writing too small or you don't understand, please do either just unmute yourself and shout out or stick a message in the chat. And I'm happy to reiterate something, explain something better or anything like that. If you have a more kind of open exploratory question, keep those for the end. We will have plenty of time and I'm happy to discuss as much as we need to. So yeah, let's have a start by looking at this lovely complicated diagram here. What this represents to me is a three-layered architecture. And we're going to be discussing kind of what a data layer actually is, what it's for. For me, when I see this, I see three layers. We've got a kind of presentation layer here. And this is, this is your browser. This is your thing. This is the code that decides what gets displayed on the screen. Generally, it's running in browser. It's on the client side, which is distinct from kind of the logic layer. This is your business logic. This is, it's doing the calculations. It's moving the data around, and it's a more business level concern. And then under all of that, we've got the data layer. And I'm going to use D for that. I'd often call it persistence layer, but if I wrote another P, that would get confusing. And that is how we save the data. That's your database. So we've got up here, this is your browser. We've got further down, this is your server side, and then we've got your database. And it's not as simple as just three layers that are independent, because they all have these kind of connections between them. So the front end is often connected to the server with an API, or something like a DTO in Java is quite common. And then you've also got some kind of mapping from the logic level to the database. And so the data layer handles all of the persistence. I will say as well, try and keep your microphones muted if you haven't. Everyone have a check. Someone doesn't. If you want to ask a question, that's fine. But if it's just background noise, try not to. So yeah, this data layer here, we're going to call this the data layer. And it's going to include that bridge as well. So all of this bit here, we're calling the data layer. And that's what we're going to be discussing today, is how that works and how we can build it better. So yeah, this is our data layer and our bridge here. It doesn't really matter what we call it. Everyone has 10 different names for the same thing. We can't even decide on what a unit test is and what an integration test is in tech. It's all just made up anyway. But the gist of it is that it bridges from the logic layer there down to the persistence layer, or the data layer. It's all of this. So I'm going to make some sweeping generalizations here because I do like doing that. People generally like writing the logic. Developers enjoy writing logic code. It's all easy. It's all happy. Everyone's happy. And above that as well, up here, there's the presentation. Now, people generally like writing presentation code. And some people, I certainly used to be one of them, some people like writing persistence code. They like writing a data model. Nobody likes writing this mapping. It's awful. Everybody hates writing database mapping code. You can write an ORM, but the very existence of an ORM suggests that maybe nobody likes writing that mapping code. But they never work, right? And even when they do work, they break and you can't debug them, and it's just horrible. Nobody likes that mapping. But why, if nobody likes that mapping, if nobody likes, these sections here, then why are they there? If nobody likes these, why are we accepting them? Why are they still there? Most of the time, when there's something that's really complex and fiddly, some kind of really awful looking bit of code here. Is that someone saying something? No? Okay. Yes? No? If you're not trying to say anything, can you please check your mics? There's only one. Yeah.
I think it's just background noise. Can I suggest everyone to mute yourself if you don't want to say
cool.
something?
There we go.
Sorry about that.
No, that's okay. Thank you. Okay, cool. So yeah, generally, if we've got some kind of horrible bit of all fluffy code here that nobody likes, what we'll do is we'll just wrap it in a library with a nice clean API there. And we'll contain all of the complexity within this library. But why aren't we doing that here? Why are we writing all this? I mean, and we do try. We try and do that with ORMs and that kind of thing. But it never seems to really work. It never seems to really stick. And the core issue here is that actually these layers all disagree. They're all dealing with the same data. We're not spontaneously turning some data down here in the persistence layer about users into some data up here about dogs. Like, they're all storing the same data. They're just storing it in different representations. And that's where that complexity is coming from. And we just tend to accept that there is complexity there, that they're always going to be stored in different formats. But why? Why do we do that? And I'm going to get kind of radical now. So I'm just going to flat out say that the perfect data layer doesn't exist. But by that, I mean two things. So first of all, I mean that the ideal way to reduce complexity is just to, delete a piece of code. Therefore, that's what I mean by it doesn't exist. The other thing that I mean is kind of automation. I'm going to try and draw a cog here. I immediately regret trying this. You get the idea, it's a cog. Cool. So yeah, the perfect data layer doesn't exist in that it's very minimal code and it's automated and you just don't have to think about it. How do we achieve that? Well, first of all, we're going to put data in the same format everywhere. So get rid of this idea of triangle, square, and circle. We're just going to require that our database stores it in the same representation that the logic layer uses and the front end uses. And then I'm just going to go a step further and actually quite precipitously have already crossed this out, but we're just going to get rid of the logic layer. We don't need it. And I'm not going to say that you don't need any business logic, because you probably do, but you're also probably overusing your server side. If we had a way for our presentation layer to directly connect to the data and for the data layer to directly connect to the presentation layer, how often are you actually going to be using this bit? You're going to be using it for the actual business logic. You're not going to be using it for the CRUD of the app, which is the create, read, update, delete operations, the basic data operations. If you had this cycle working, you wouldn't need a server in order to do this. If your browser could talk directly to the database, you wouldn't need a server to do those CRUD operations. And then this logic layer is just left for the actual logic. And I'm going to say that there is probably so little logic in your app that the data layer doesn't matter. You could be writing SQL by hand, but there's probably so little of it that we just don't have to worry about it for now. So I'm not going to worry about the server. And so it's very easy for me to sit here and tell you that you don't need a logic layer and that you're probably overusing it. So I'm going to give you a real example of this is what Lexoral's logic layer looks like. So in terms of the front end, there are four front ends, 4 apps. So we've got the landing page. We've got the landing page is kind of, it's what you see. It's also the blog, that kind of thing. We've also got the dashboard, which is where you upload your audio. We've got the transcription pipeline, which is what actually performs the transcription, and it's kind of the compute. And then we have the editor, which is where you go in and you fix the errors that the transcription pipeline made. And what API endpoints do we have here? Well, let's walk you through them. So first of all, on the dashboard, you can upload your audio to our servers. That's one API endpoint that we have. Another one is the one where you decide that you want to add some credit to your account and we have to do some signing. We don't want to leak our private cryptographic key. So we have an API endpoint for, please create a checkout on Stripe for me. After that's succeeded, we have another API endpoint that's just called by Stripe, which is someone has just successfully paid, please add credit to their account. And we've also got one over here, which is when you load up the editor, it has to get some data out of a bucket. We need to do access controls, so there's an endpoint for that. Although I want to get rid of that one. That's it. That's actually all of the logic layer. That's everything that can't be done with just a combination of a presentation layer and a data layer. So Lexoral's a reasonably complicated app, but actually this isn't the entire logic layer, but these are the external endpoints. So there's more functions, they kind of call each other. But this is the bits you have to worry about. Your logic layer probably isn't as big and scary as you think it is. So let's have a think about what, if we get rid of that middle layer of logic, what would the dream data layer look like? Well, it would have a really huge presentation layer because it's big. There you go. It's got a lot of stuff in it. And then there is really no separation here between the presentation layer and the database. That you kind of treat them as one, which is because they're storing the data in the same format. What ends up happening is that you almost treat your data layer as the back end of your presentation layer. So you're dealing with your presentation, your displays, all of that. But on the front end, there is just a little library running, which is keeping these two in sync both ways. So our dream data layer is just going straight from the presentation layer to the database, behind the scenes, automatically keeping the two in sync. And I mean, it's probably obvious by now, I haven't said it explicitly, but this is exactly what Lexoral is doing. So behind the scenes on the front end, you have some code which is keeping the representation of objects in the front end in sync with the database. And so going back to what we said before, we have removed a vast amount of code. We've essentially removed the middle box and also both of these mappings. And we've shifted all of that complexity to mostly the database. We said the database needs to be able to deal with our objects in the representation we're giving it. And I don't care what it does, it's a black box, but it needs to deal with our objects in the representation we give it. And it also needs to be able to keep it in sync with the front end, and the front end needs to be able to talk. It would need some authentication. That's a lot to ask of a database, but it's actually exactly what Firestore, sorry, there was no image of Firestore, can do. Oh, there we go. Sorry, I've got to remember to press buttons in multiple places to get that to work. it's exactly what Firestore can do. So Firestore is a cloud native database, and it's not SQL, it's NoSQL, which is it's a document database as well. So essentially, all you have to do is think of your database as one gigantic JSON object. So you just have one huge JSON object which stores all of your data in it. You know, it's just like users, something like that. That's what your database is. And then you can subscribe to a specific path on that, or you can push data at a specific path in that image, in that object. But you can also actually subscribe to changes on that path. So it's event-based. So you can say at the path, users/my user ID /settings, notify me whenever anything changes. And that's WebSocket based. So you're listening to Firestore for whenever anything changes and you'll get notified about it. So if we go back to what we had, that's that circle at the bottom there. That listening gives us this bit, because we can listen for changes, and we can also just push. You can do your CRUD operation straight from the kind of client side connection, and it also has a load of other stuff that you kind of need in order to get rid of that server side. Like it has built-in authentication. Let's try and draw a padlock here. Oh, that's not bad. I'll take that. So it has built-in authentication. It can check people, and it can have kind of, checking that you're only editing your own data and that kind of thing. So Firestore is great, but what really took it to the next level was what we're running on the front end, which was Svelte. So Svelte is a web framework. It's really hard. I've been talking about Svelte for a couple of years now, and it's really hard because I'm never quite sure how many people will know about it, because when I first started, it was like pre-alpha, nobody knew what it was, and it started to kind of, in fact, I think it might be like one of the most fastest growing web frameworks now. But essentially, it's a web framework. It's like React, but what makes it different is that it's reactive. And the way that someone described it to me, which I thought was really good and really helped, was that it's like Excel. So I don't know if you've used Excel a lot, you probably will have seen at some point that it has an idea of a dependency graph. Say that we've got 3 cells here, and it's like 3, 2, and then we've got this operation here. This cell is like adding the 2 together, and it says 5. Then when you change a cell in Excel, it doesn't actually, it doesn't scan the whole thing all over again. What it does is, say I change this one to a 4, then it just follows this dependency graph up. And it's like, okay, this one's changed, so this one must change. Let's recalculate this cell. Oh, okay, it's now 6. And that's exactly what Svelte does. So Svelte will look between your variables, and it'll find kind of the dependency graph between your variables of which ones depend on other ones. What that means is that it doesn't just stop there. It actually goes a step further, and it knows which of your variables are bound to specific bits of HTML. So if I change this variable on the right here, if I change this variable, it'll follow it through, update this variable, follow it through, and then update something on the page directly with the DOM. So you can see how, if we, instead of just changing a variable, if we had Firestore, or our Firestore database, which updated a variable, then just with that, we actually have a system where a change in the database can be followed all the way through and update something on the page. And that you essentially get that for free. The other thing that Svelte has, which are really good, are stores, which are like little data containers, which you can put like a number in or something like that. And you can write to those data containers, but you can also listen to them. And you can then pass those around, and you can essentially listen to events. It's a kind of fairly common reactive concept. But yeah, again, going back to the database, imagine if that database was updating the store, we now had a container which represented the data that was currently in the database. So you can see how Firestore and Svelte fit together really, really nicely there. And now let's walk you through what we did. So we sat down, we thought about, what's going wrong with the data layer, what could make it better. And so, yeah, we thought, okay, we're going to have a Svelte store here. And that Svelte store is going to be storing a Firestore document. So that's what Firestore calls kind of a subsection of that big JSON object that is your database. Let's say it's my music preferences or something like that. There you go, that's meant to be a musical note. Perfect. So if we make a store like this, yeah, and then if we connect to Firestore, so here's our DB up in the sky, and if we listen for changes to that database, then whenever they happen, we can set the value inside of this store. And then we now have a Svelte store that we could bind to an HTML element. Say we've got an input element here, like a text box, and there's some text in it. We could say that whenever this store value updates, then we're going to be binding that to the text box. So whenever the database value changes, we're listening to that, we hear about it, we update the store, and it comes down and it updates the text box, changing what's in the text. So this text box here is going to be constantly staying in sync with the database, just like that. And that's happening entirely kind of from the database to the front end. Yeah, that we have something pretty much exactly like this. On the dashboard, there's a display of how much credit you have. And that credit is showing you, it's how much money you have essentially in your account to spend. And obviously we don't want you to be able to go this way and change the amount of credit that you have directly in the database. So it's just like a one-way read-only store. So this store here is read-only because it's just going one way. But that doesn't work for everything. The example that I use a lot is your volume preferences. So say this is like a volume slider here. There you go, it's meant to be a slider. So when you change a volume slider, you do want it to store it into the database. Otherwise, it's not really a data layer. It's like a data access layer. So what we're going to do is Svelte by default can support kind of read-write stores. So that connection there happens automatically for us in a read-write store. And what we need to do is if we listen for changes on this store, or even hook into here, then we can go both directions and we can say, well, whenever we get a change to that store, let's push it to the database. So now what's happening is when I move this slider back and forth, it's coming up here. Svelte is updating the store for us. We're listening for those changes and we're updating the database. When we update the database, it's then coming down to here, updating the store, and it's going that way, which seems a bit pointless. What I've just described there is a loop where we update this slider and through a really convoluted way, it goes across the world and then it updates itself. But the real benefit here is imagine that we're not the only ones connected to it. Let's say I have Lexoral open on my computer and my phone, and I want the two in sync. Well, this database isn't just updating us, it's also updating every other client that's listening to that specific document, which would be, this specific user's volume settings. So the database is updating everyone that's listening to that, not just me. The other thing that you might be concerned about is latency. So this looks like quite a long path for something that should be instant. But what the client library does with Firestore is it sits in between here, and it actually does something called latency compensation. So it tracks which documents you're listening to, and when it gets to here, it will see that you're actually listening to the document that you're currently writing to, and it'll short circuit straight through the library back to you. So the store will get notified here before it's actually made it up to the database. And then when the database comes back in, the library just handles that, knows that it's already told you about it and doesn't tell you again. So the circuit looks like that locally, but the benefit is that we actually also get it to go to every other person that's listening. And essentially what that lets you do is by binding all of this together, we have a store here, which can automatically stay in sync with the database across multiple devices. And it happens pretty much instantly. So we looked at that, it's like, yeah, great, okay, that solves all of the problems, job done. But it doesn't. So there are some limitations for sure. Firestore is not a magic bullet. One of the limitations, which is really important, is each document here, you can only write to it 1 time per second. There you go, once per second. And that probably sounds weird because Firestore is for, giant, it's for giant corporations. It's billions of writes per second, millions of users using it, which it is, but each document can only be written to once a second. And that's because that's how long it takes for them to get kind of eventual consistency around the world when they replicate it. So yeah, there's that limitation. There's also another issue, which is that Firestore charges you for every single read and write that you do. It's not a lot. It's like 5 US cents per 100,000 reads, or something like that. But you can imagine that if a user is sitting here and playing with this slider back and forth at 60 FPS, it's performing 60 database writes a second, which gets expensive. I mean, it doesn't, but it's, nobody wants to increase their database traffic by 60 times as much for no reason. So what we actually did was added in a caching layer to this store here. I'm not sure how I'm going to represent this. I'm just going to draw a circle. You know what it means. It's the cache. It's pending. So what happens instead is that when we edit this slider, we store it in the pending changes. And those pending changes just stay locally. But because they're part of the store, so we still get this bit instantly. We're still going through the store and still updating itself instantly. The only bit that isn't happening is this push. We're not pushing it up to Firestore immediately. That becomes a manual push, like a manual action. So we're saying, you can manually push from here up to the database when you want to, and that'll push all of the little changes that we have stored in here all at once. That wasn't meant to be like a radioactive warhead symbol, but it is. So when you call push, it'll push up the database, and that'll push to everyone else. Because remember, that's the important bit. We're still doing this cycle instantly. So if we're pushing that to everyone, that's fine. That solves our problem. Our 1 write per second is now solved because we're only pushing, when we need to, and we're also limiting the amount of reads and writes happening because as much as possible, it's contained within this square. But if you think back to what we said at the start, the dream database layer is minimal and automatic, and this is really not automatic. So let's make it automatic. I mean, you could just say, oh, make it automatic by having it automatically push, but that's what we had to begin with. So instead, let's put it on a timer. If we have a 1 second debounce timer, here we go, and trigger that timer every time the store gets written to, probably can't really tell that's at 1 second. There you go. So every time the slider changes, it updates the store, which just restarts this timer, and it lasts a second. And every time you write to it, it restarts the timer back at a second. Then when that timer runs out, then we can call push. So when that timer triggers, when 1 second has passed, it calls push for you. And that's 1 second of no changes. So you can imagine I'm sitting here and I'm using my slider, and then I stop, wait a second. That timer eventually is allowed to run out, and it triggers the push. Push comes up here, goes in there. And 1 second is arbitrary. We let you decide. Because you could have it be at 10 seconds, that would be fine. It would just mean that there's a 10-second delay between you changing a setting here and it getting pushed to your mobile phone. So for some things that's more urgent. For something like your volume settings, it probably doesn't matter too much. That is pretty much what we have with Lexoral. We have a database up here, which is storing JSON objects. we're listening to it through their library into a Svelte store, which is then bound bidirectionally to an HTML input slide or something like that. Whenever the value changes, we're starting a 1 second timer here, which then triggers the push, triggers it back up to the database, which then triggers it to come back down and start again. But also triggers it to go and tell everyone else that it's changed. There is a little bit more that we actually use, because obviously this store here, in the way that it's drawn, it's currently storing a document, it's storing a JSON object, and you can't bind a JSON object to a slider. So there's a little bit extra which kind of lets you extract a specific field out of the document and bind that. But you can read the blog post if you want to know more about that. It's a bit kind of complex to talk you through. So yeah, I'm going to show you what that actually looks like. I've got Lexoral open here. Do forgive that it's MVP. It's still a bit jank. It's a bit ugly as well. Not nearly as pretty as the front end. But so I was talking to you about the volume settings here. This is the volume setting that we're using, and I've got 2 tabs open. They're not talking to each other directly at all. I could have one open on my phone, but I think that would be a bit overkill and certainly hard to show you. But if I come in here and I start wiggling this around, I start changing my volume settings, you can see on the right-hand side, nothing is happening. Once I stop, if we wait 1 second, there you go. So as I was wiggling that was constantly changing a store inside of Svelte. And that 1 second timer was constantly restarting. It's restarting with every frame that I'm moving it, it's restarting that timer. Eventually, when I stop moving it, even if I'm still holding the mouse button down, I'm still potentially moving it. But if I stop moving it, on the right-hand side, that 1 second timer hits 0, sends it up to the database, sends it up to, there you go, sends it up to the, where am I looking? So I've finished moving this, comes up to the store's constantly changing, the timer eventually runs out, it triggers push, it gets pushed up to here, it then goes over to the other, it gets broadcast to everyone, but especially the other tab is what we care about. And now if you imagine that this bit's the other tab, it comes in, it updates our version of the store, and it triggers, because we've bound this to the value in the store, it moves the slider for us and it changes the volume. So the data layer there is pretty much non-existent. In order to set that up with the library that we've written, it's about 4 lines of code. And all it is leveraging these technologies that kind of mesh together nicely by themselves. So the real question, and I've got a picture of a mirror here, you just got to imagine that you're in the mirror, there you go, is should you do this? Is this data layer for you? And I mean, the answer is probably not. You know, if you have the exact same architecture as us, you have very similar requirements as us, then yeah, you know, like feel free if you want. It's up to you. I'm not gonna tell you not to. Like we are open source. We're on GitHub. There's code snippets in the blog. You can just go on there and you can take the code. But you're probably not on the same architecture. So what then is my advice? Well, it goes back to what we did at the start. And it's that your first step should be to figure out what you want. So we started by thinking about those 3 layers. And we figured out, actually, you don't need that one. You know, it's to figure out what you want at the start rather than what is available. What's available it's nice if you know, but just going off what you see other people using won't get you the right option. You know, you start with what you want it to do, not with what there is. I mean, I'm infamous for doing that. I like to call it like working from first principles, but I think people generally just call me a picky bitch. So yeah, like, because the problem is that once you've thought about it, the existing solutions often look crap. Like for example, you can't really see, but our sofa in the living room, I thought about sofas and what I wanted, and I decided I wanted a 3-seater sofa with 2 seats like this and then 1 chaise like that. But I also wanted these 2 to recline like that. You can't really tell that's a sofa, but you get the idea. Turns out that actually, like this middle one reclining is a real pain. Every sofa shop we went into told us it didn't exist. But I was set because I'd thought from first principles, what do I want this to do? And eventually we ended up, I was on the internet until 2 a.m. with Google Translate, and I found a small Spanish company, like family-run company, who made all kinds of weird sofas, including one like this. And a favorite of mine, a sofa bed, like sofa that you pull out, but it pulled out into a bunk bed, pulled out and lifted up, and then it was a bunk bed. Like, what? It's crazy. Anyway, we found the one reseller in the UK who actually sold this family's sofas. And I mean, they literally, like, they went over to Spain once a year and like drank wine with them and made friends so that they could be the reseller. A very weird industry, but we eventually got it. And like, I have my sofa, I love it. And it's a talking point because I didn't start off by going to the shops. I started off by deciding I wanted this. And then I went to the shops and all the shopkeepers told me it didn't exist, but it does. And I'm happy about that. Anyway, very off topic. The point is, we often make decisions based on availability bias. So that is, you look around here, you're here, you're a caveman or whatever. I don't know how you indicate a caveman, long hair, there you go, and a beard, something like that. And you see that lots of people are eating like apples, but not many people are eating like, I don't know, grapes. Your instinct is don't eat grapes, which makes sense because like grapes might be poisonous. I mean, we know they're not, but as a heuristic, that's a good idea, is look at what's available. The thing that's used most is probably the best. But like, that doesn't make sense. That doesn't make sense when it comes to data layers. Your life isn't at risk if you use the wrong data layer. So challenge those assumptions in a safe way. Like, a weird data layer isn't going to kill you. Try things out. And if it doesn't work, you can just fall back to using the other things. But sometimes you'll get something that looks really weird and is really cool and works out really nicely. So challenge those assumptions, work from first principles. And yeah, that is all from me. So thank you very much for coming. I hope that you've enjoyed it. I'm going to plug things now. So the blog post is, you know what, I'm just going to write lexoral.com here. Lexoral.com /blog has the blog post. It is the one about data stores. It should be fairly obvious. You can also follow us on Twitter. So that's like at Lexoral. And then I'm also at Steve Waterman. I'm not at Lexoral. I mean, I am, but personal versus business. There we go. And as you can probably see on the screen kind of up there, we do stream on Twitch. It's similar vibes, a bit less polished, but 3 times a week, we're live on Twitch, just kind of showing work and doing work, chatting with people. So that's just twitch.tv /Lexoral, as everything else is. So yeah, and get in touch if you want to chat. Watch the live streams, but we have plenty of time for questions. So if you do have any, I'm more than I want to hear them. I want to chat with you. If you've got questions, it's not just you, so please do share them and let's have a chat about it. I'm sure I've outraged a few of you. So yeah, thank you very much. There you go. There's some links that way as well. Yeah, cool.
First of all, thank you for a very interesting talk about Svelte and Firestore. Just out of curious, so you said that I can see that this is brilliant for like prototype application, and like you say, you figure out that you don't need the business logic layer. I guess it's like you say, it's going to be a lot different for other people, for example, enterprise applications. But just out of curious, so do you have plan to have other application, for example, iPhone or Android apps, and when you do, how you gonna copy and paste the business logic, if any?
Yeah, no, that's a really good question. So like, yes, I'm not going to say that we don't have a business logic layer. We absolutely do. It's fairly significant. There is one part of it that will essentially like parallelize across 300 servers automatically. It's huge. Like the transcription pipeline is very complicated, but the actual, as far as the front ends are concerned, it's kind of a separation of concerns. In terms of how it would work with like an iOS or an Android app, is Firebase and Firestore still have that same support? This, with Firestore, they have a web library. They also have an Android library. They have an iOS library. Your phones can be communicating directly with the database, just like the website is. And it's reasonably scalable. There are some features that you might want to get some kind of server involved with. We're all Lexoral is like cloud function based, but if you do want to have servers involved, then you can. And I see quite a few people doing that with Firestore in order to get like rate limiting in, because obviously that's a concern with having the database kind of publicly exposed. Well, it's not quite. You still need to be authenticated. So yeah, I think that the answer is that actually I'm not planning on having an iOS or an Android app, but if I was, the same setup works. Rather than using Svelte, I'd be using some kind of reactive iOS Android library. But the Firebase Firestore side of things is going to be the exact same. And in terms of business logic, it would probably be the business logic layer generally is like cloud functions for us. So they could just be getting called as well the exact same way. So it's surprisingly flexible and surprisingly kind of, I guess, client agnostic. I hope that answered the question. Let me know if it didn't.
Yeah, it does. Thank you.
Fab. Anyone else? Upset anyone else?
One for myself, Stephen. What happens when two people push changes at the same time? How could you talk us through what that looks like?
Yeah.
That'd be handy.
So yeah, I guess if we go back to this diagram, if you imagine that you've got two people changing this slider at the same time, so kind of there's someone changing it over here as well, then it'll be pending for both of you at the same time. And this is...
So we can't see the diagram. Sorry.
Oh, I'm sorry.
That's all right.
Sorry, there we go.
Cool.
Thank you for letting me know. I would have completely blanked on that. Yeah, you've got two people changing these sliders at the same time. One person on that tab, one person on that tab. Is going to be in the pending stage on both of them at the same time. And this timer is going to be happening at the same time. Essentially, what it comes down to is who pushes first. And this is something that you can actually have some control over, in that it's implementation specific. So whoever's pushing it first, let's say this person, they made their change first. It'll get pushed up to the database. It'll then come down to the database and it'll change this, but this pending data still exists. So the way that we've got it set up is that the pending data, these are essentially overrides on what we currently think is in the database. Mm-hmm. So the first person's data will override their fields and it'll come down. And if we're then overriding them again, you just won't see any change. Eventually this one will push and then it'll come down. But this is, I mean, it's a whole field of research. I think in general, they're called, it's testing me. I think they are CRDTs, which is conflict-free resolvable data types or something like that. Essentially, it's, I'm using Google Jamboard here. And, the question is, if I'm scribbling up here on the tablet that I'm using, and then I come in with the mouse and I rub it out on my computer, and both of them are drawing at the same time, how do you decide what happens and how do you store that? And it's a whole field of research as well. So we've kind of gone with the simple solution of actually, we'll just let it push, just let it come down, and then the overrides will then push up again. But you can imagine having, almost merge conflicts and asking what you want to happen. And it gets significantly more complicated when we're looking at the actual text being changed on two computers at once. But I think that's a talk of its own, talking about the text.
Cool, thanks.
Cool. Anyone else? Any questions? Anything at all? It doesn't even have to be about this, to be honest. I'm just happy to chat.
Just again, just out of curious, any disadvantage at all with this approach sometime?
Yeah, absolutely. There are, I think the biggest one, and the one that probably scares people the most, is the fact that, is that going to work? No? Okay, let's go. Oh, no, it did. There we go. So Firestore is gigantic. Firestore is up here, and it can handle, 1 billion writes per second, no problem. That sounds great, but frankly, I don't want 1 billion writes per second. I'm not going to need them. And if someone did, if Lexoral did start writing to the database 1 billion times a second, I can't afford it. So there are concerns about the fact that, and this is what I was talking about rate limiting earlier. Imagine someone just tries to DDoS attack Lexoral, and there are protections in place. Google is on Google Cloud Platform, and they have kind of their brick wall sits in front of Firestore, and will try and stop it if they can, if it's like low level, it's IP spam. But if they're actually sending valid requests and are logged in, then it's very, very, very difficult to stop all of these people from spamming you and inserting valid data into the database. And there are various ways of counteracting it. So obviously you have the Firestore, I think they call them like security rules. It's like a shield symbol. And that's how we handle the authentication. So for example, Firestore handles the authentication, and it will check that the UUID of this person's request, their user ID that they're logged in as, matches the path that they're trying to access. So if they're trying to access users/ID, it checks their UUID against this in the path to make sure that they're only reading or writing their own data, and it's all configurable. But it's very difficult to distinguish between a large amount of valid traffic and a large amount of malicious traffic that is just trying to jam up your data. And even if you do try to say store something in the database of the count of how many times they have written to the database in the last day, then when they send that request, you still have to check that value in Firestore, which is still a database read. So even if their requests are getting rejected, you're still performing database reads, and it's still costing you money. And Google's response to the people being worried about that has essentially been, it will cost us more money to give you protection from this than it will to just refund you every time it happens. So if it happens to you, get in touch and we'll give you your money back, which doesn't really inspire confidence. And I think that's probably my biggest concern as well, is that someone could come along and try and just spam with a load of data. Lexoral is more protected than other people because some people are doing, fully open to the public Firestore instances, whereas ours is behind user IDs, and you need to be authenticated to read or write anything. So if we can stop you from having accounts, then we can stop you from using it. But it's still a concern, and that's why a lot of people will kind of build cloud functions on top of it. But yeah, I mean, it's the kind of thing where you can solve it by saying Firestore isn't allowed to cost us more than $10 a day. But then if that limit is reached and your site just shuts down, people will be upset. So that's probably the main weakness of using Firestore specifically. But it's not really a weakness of, this data layer that we've kind of constructed. So it's not really a weakness of this so much as it's just a weakness of Firestore. I'm not really sure if there's too much of a weakness of doing it this way. It's a little bit bodged. If what you're trying to do is actually have two clients synchronized with each other and collaborating, then you want to be using CRDTs and some kind of pub sub queue or messaging system rather than just storing to the database and listening. But for a prototype, using a database just for messaging is fine, especially Firestore. I think that was quite a lot of answers, but I hope that was useful.
Yeah. Sorry, did you say that we have or we don't have rate limiting for Firestore?
Pretty much, yeah. So it gets complicated. You can rate limit the entire thing, and you can say, I don't want more than this much use. I want to put, budgets on it, and alerts and billing and metrics, but that isn't per user. There is no easy way to say, don't let this user make more than 100,000 writes per day to the database without doing that yourself? And then if you do it yourself, how do you do it such that in order to check a request, you don't have to read a document in the database? Because if every rejected request was still causing a database read, it's still going to cost you money, even though the requests are getting rejected. So
I see.
there is no way, and Google's acknowledged that, and they've essentially said that it's not worth their time to fix it because it happens so rarely that they'd rather just give you the money back and cancel the bill if it does happen. And if you go to them and you say, I've got malicious traffic, they'll be like, okay, we'll just cancel the bill. No, you don't worry about it. Because apparently it costs them less money to do that than to actually fix the problem. So yeah, it's a bit of a weird one, really.
That's really cool to know that Google's that generous. Thank you.
Yeah, I think it's, well, yeah, it works as a policy, but it's because so many people are concerned about it that they're doing it. They've kind of been forced into doing it to ease concerns over whether or not it's safe to use Firestore in a public thing, because it's such a core part of Firestore, the fact that you can access it from the web, from the phone directly, that they want people to feel safe using it that way. Yeah, cool. Anyone else? Any other questions? Okay, cool. Well, I mean, if you do have other questions, there is a load of links. You can, you've got Stephen at Lexoral.com. You can get in touch on Twitter. You can get into, we've got a Slack. I don't have a link for the Slack, but if you go on the website, there's a link to the Slack. It's just like a user's Slack where you can chat about Lexoral and that kind of thing. We stream on Twitch, which is why this is so over the top. And there's there's the dates. So it'll be on Friday, 8:30. But yeah, I would love to see you there, and I hope that you've enjoyed the talk. So thank you very much for coming.
Thank you. Thank you for the talk.
Thanks.
Thank you very much.
Thanks all.
Thank you. Thank you very much.
Cool. Excellent. Thanks very much, Stephen. That was really good. Really good. I'm still really impressed by the kind of interface that you've built up. It's totally different to what we usually have, you know, the usual slide deck and then your face at the side somewhere.
Yeah,
that was really good.
It's much nicer to do it this kind of way.
Yeah,
it's a lot more effort, but I think it's worth it. I mean, especially given that I had most of it set up already.
Yeah.
Having the tablet and drawing was nice, although that was a bit new and bodged for me, but it worked out, I think.
I quite like it though. It is quite nice, to be honest.
It makes it a lot easier to kind of improvise and adapt.
Because generally people are pressing a button, someone flashes up, and then another button, something flashes up. What I was going to ask was, you see the screen that you've got on now, right? Because I'll obviously say thanks to yourself and kind of tag you on LinkedIn. Could you screenshot that and I'll put it in as a photo because it might just bring a bit of attention to it as well, you know? Just got all your details. It's yeah. I mean, you just never know who picks up on these things, right?
No, absolutely.
If you could send that across to me, that would be really, really helpful.
Yeah, I'll do that.
I'll pop that out this afternoon, and we'll get a few likes and shares.
No such thing as bad publicity, Stephen.
No, of course not. Never. Yeah, that was fun. I enjoyed that. It was nice. Yeah, it's nice. Don't really know what else to say. It was good.
No, it's good. No, really good indeed. So yeah, no, perfect. Listen, thanks again. Do appreciate it. So yeah, I mean, I suppose if you do have something again in the future that you fancy kind of talking about, just get in touch. Yeah,
absolutely.
Again, we can kind of facilitate whenever suits you, to be honest. So
okay.
So yeah, don't hesitate to get in contact.
Yeah, thanks again for me as well, Stephen. Much appreciated.
Well, thank you for inviting me. Yeah.
Cool.
Brilliant.
Nice one. All right, perfect. Well, listen, thanks again. And I'm sure we'll catch up again at some point in the future.
Fab. Right.
Brilliant.
Have a good day. I'll see you around.
Cool. Will do. Cheers,
Stephen.
Bye-bye.
Bye.